Hey guys, welcome back. So we're going to be talking about exponential and logarithm functions. Now, a logarithmic function is the inverse of an exponential. So previously, what we were doing the other day is graphing exponentials, which were in the form of y equals b times a to the x. Okay? Log functions are just a different way to write this. And specifically, it's a way to help us find what the exponent is. So, if our log function is in the, our exponential function is in the form b to the k equals n. And I know I'm using different variables. It's just the pattern that we're trying to use. This correlates to the log function log base b of n equals k. Again, log functions are a way to solve for our exponents. They're the opposite of exponents. So for example, the opposite of adding would be to subtract, or multiply is to divide, or if I was trying to square something, it would be the square root. So the way to get x out of the exponent is with logs. And this is one of the, probably the first things that is unique to Algebra 2 in general, is that it's something you probably haven't seen in Algebra 1 or geometry. Everything else you've kind of seen we've built upon. This is something that's completely new. So we're going to look at like the easier versions throughout, but we're just going to make sure that we can have a kind of base understanding of what this logarithm does. So the first thing we're going to do is practice going from exponential form to log form. From exponential form to log form. So now here, we just need to make sure that everything matches up. The base of our exponent is the base of our log. And then we switch the next two. So here we go. Exponential form. 3 to what power equals 8? Well, 3 to the third power equals 8. So in log form, 2 is the base of our exponent, so it becomes the base of our log. And then we switch the next two. So log base 2 of 8 would then equal 3. All right. 2 to the fourth equals blank. 2 to what power equals blank? Well, here, 2 to the fourth equals 16. So log base 2 of 16 equals 4. Two to the 0 equals 1. So log base 2 of 1 equals 0. Here we're looking, what number raised to the negative 1 power equals 1/2? So we need to know the type of exponents, or negative exponents do what? Well, negative exponents make fractions. So this would be 2 to the negative 1 is 1/2. So log base 2 of 1/2 equals negative 1. So then I'm looking at what to the 1/2 power equals 2. Well, remember 1/2 as an exponent, this would be like a bow tie. So this could be rewritten as the square root of what to the first power equals 2. Well, the square root of 4 to the first power equals 2. So 4 to the 1/2 equals 2. So log base 4 of 2 equals 1/2. So 2 to any power equals n. So let's do 2 to the smiley face. Means that log base 2 of n equals smiley face. Again, this is just to help us get our pattern. So what I'd like you to do is to pause the video and try these practice problems. So you are rewriting the logs in exponential form and the exponentials in log form. Let's go ahead and pause the video and then we'll come back. All right, so let's check our answers. So if we have log base 3 of 81, remember 3 is the base of our log, so it should be the base of our exponent. And then we switch the next two. Exponential form does not have log in front, and log form does. 2, 4 is the base of our exponent, or our log, so it's the base of our exponent. And then we'd switch the next two. 3, 8 is the base of our exponent, so it's the base of our log, and then we switch the next two. And then 5 is the base of our exponent, so it's the base of our log, and then we switch the next two. Remember, logs are set up to solve for the exponent. So they're going to equal the exponent. All right, so now what we're going to do is try and evaluate these logarithms without using a calculator. So what I like to do is I like to set it equal to x in the beginning. So log base 5 of 25 equals x. And then what we're doing is we're writing it in exponential form. So this would be 5 to the x power equals 25. Well, 25 is 5 squared, so this is the same thing as writing 5 to the x equals 5 to the second. So since our bases are the same, the exponents have to be the same, so x has to equal 2. Which means log base 5 of 25 equals 2. Number 7, log base 4 of 64. I'm going to set it equal to x. And then I'm going to write it in exponential form. So 4 to the x power equals 64. Well, I could rewrite that 64 as 4 to the third power, which means here x would have to equal 3. Eight, set it equal to x. So 4 to the x power equals negative 16. Well, there is no exponent that will ever give us a negative answer. So when I'm trying to do log of a negative number, this does not exist. Which we can abbreviate as D and E. So the moral of this is that we cannot take the log of 0 or a negative number. because there's going to be no exponent that will give us a number equals 0 or equals a negative. So this number here cannot be negative. It can certainly equal a negative number, that's okay, but we cannot take the log of a negative number. All right, so let's look at 9. Set it equal to x. And then we'll write it in exponential form. So this will be 10 to the x equals 10 to the third. Well, here our bases are already the same, so this means that x has to equal 3. So 10, set it equal to x. So 3 to the x equals 1/3. Well, 1/3, we want to write it as 3 to some power. So to get fractions, we have to have negative exponents. So 3 to the x would have to equal 3 to the negative 1. So then x has to equal 1. Or excuse me, negative 1. All right, 11, set it equal to x. So this would be 9 to the x equals 3. Now here, I can't break down 3 and write it as 9 to some power. I can, however, break down the 9 and write it as 3 to some power. So I could rewrite the 9 as 3 squared. Now since it already has x in an exponent, it'll just be a 2x. And this will equal 3 to the first power, because 3 to the first power is 3. Well, then our exponents have to be the same since our bases are, so 2x has to equal 1. So x would equal 1/2. And then 12. Set it equal to x. So this would be 16 to the x power equals 1/2. So now this one's a little bit tricky, just like the previous one. I can't write 16 as 1/2 to some power, and I can't write 1/2 as 16 to some power. So what I'm going to do is I'm going to try and rewrite both of them. So 1/2 fractions are negative exponents. So this is the same thing as writing 2 to the negative 1 power. So now I need to write 16 as 2 to some power. So 16 would be 2 to the 4th power. And then I include that x that's already in the exponent. So since the bases are both 2, the exponents have to be the same as well. So 4x has to equal negative 1. So then x would have to equal negative 1/4. All right, and that is all for this video. So there was one more thing that I wanted to go over. You can notice that all of these logs have a base number written. If there is no base written, so if it's just log of 16, for example, this is meaning that it is log base 10 of 16. So So when there's no base written, it means the base equals 10. And the last one, we'll talk more about this in the future, but if it has ln of 16, ln of 16 means the natural log of 16, and this would be log base e of 16. And e is a number like pi. It goes on forever and doesn't repeat. Like pi is 3.14, e is 2.718, ... We'll talk more about this next time.